In this video, we have another test to check whether a series converges or not, called the ratio test. So typically, this test is useful for series with terms that contain something that looks like k factorial or a to the k, so an exponential term where k is the index. So we're going to be using the ratio test a lot later on when we introduce power series. Okay, so before we get into the ratio test, let's do a quick review on factorials. So the factorial symbol is an exclamation point. So this would be read as 0 factorial. 0 factorial is defined to be 1. And then k factorial is so the product of all the numbers from 1 to k. So k factorial would be 1 times 2 times 3, and then so on up to k, where k is greater than or equal to 1. So for example, so 0 factorial we already have is equal to 1. So now if you start from 1 factorial, this would be equal to 1. 2 factorial would be 1 times 2, which is equal to 2. 3 factorial would be 1 times 2 times 3, which is equal to 6. And then 4 factorial would be 1 times 2 times 3 times 4, which is 6 times 4, which is 24, and so on. And so a useful formula, which will be used a lot in the ratio test, is that k plus 1 factorial. So you can see that any factorial can be computed as taking the previous factorial and then multiplying by the current number, right? So 4 factorial is the same as 3 factorial times 4, and then 5 factorial will be the same as 4 factorial times 5, and so on. So k factorial, k plus 1 factorial, is the previous factorial, which is k factorial times the number that you're interested in, so k plus 1. So again, this formula is going to be helpful when we do the ratio test. Okay, so now let me describe the ratio test. So the ratio test says that for a series, with positive terms, we calculate the following limit. So you take the ratio of successive terms, so a k plus 1 over a k, and then you check what the value of r is. So if r is between 0 and 1, the series converges. If r is strictly bigger than 1, the series diverges. And if r is equal to 1, the test is inconclusive. also try a different other method. Okay, so this is the ratio test. Okay, so let's look at some examples where we can apply the ratio test. Suppose we have the sum k equals 1 to infinity of 2 to the k over k factorial. So you can see here that this contains k factorial. So we're going to try the ratio test. Okay, so to use the ratio test, I need to identify ak and ak plus 1. So a sub k is just this part here. So it's 2 to the k over k factorial. Then ak plus 1 is to replace every k with k plus 1. So it'll look like 2 to the k plus 1 over k plus 1 factorial. Okay, so now let's write out the ratio. So before computing the limit, we're going to write out the ratio and then try to simplify it. So ak plus 1 over ak. So let's write it out. So it's 2 to the k plus 1 over k plus 1 factorial over 2 to the k over k factorial. So let's rewrite this fraction. So also using the formula, right, so the top fraction I can write as 2 to the k times 2. The denominator here, I use the formula, so it's k factorial times k plus 1, and then I flip this fraction. So I write as a multiplication, I flip the bottom fraction. That's k factorial over 2 to the k. So the reason I rewrote the top fraction is so that I can do some cancellation. So the k factorial and this k factorial cancels. This 2 to the k and this 2 to the k cancels. So the only thing that's left is 2 over k plus 1. Okay, so now I can compute the limit. So r is the limit as k goes to infinity of ak plus 1 over ak. We just computed this ratio as 2 over k plus 1. As k goes to infinity, the denominator gets bigger, so this whole thing goes to 0. And this is strictly smaller than 1. And so this says that this series converges. So this was the first example of the ratio test. So let's look at another example. So suppose I have the sum k goes 1 to infinity of k factorial over k to the k. So again, this series has a k factorial, so we want to try the ratio test. So we identify a sub k and ak plus 1. So now let's take the ratio of successive terms. So ak plus 1 over ak, and then simplify this. So this would be k plus 1 factorial over k plus 1 to k plus 1, and then this whole thing over k factorial over k to the k. Let's rewrite this fraction using the various formulas again. So this part here can be written as k factorial times k plus 1. The denominator can be written as k plus 1 to the k times k plus 1, and then this part here, I flip it around, so it's k to the k over k factorial. So now let's simplify this. So the k factorial cancels. This k plus 1 and this k plus 1 also cancels. So now we're left with k to the k over k plus 1 to the k. Then I can combine this. So this is the same as k over k plus 1. The whole thing raised to the kth power. So now we're ready to calculate the limit. So r is the limit as k goes to infinity, ak plus 1 over ak, which we simplify to this thing here. So it's the limit as k goes to infinity of k over k plus 1 to the k. So as k goes to infinity, this is of form 1 to the infinity. So it requires a L'Hopital's rule. This is an indeterminate form. And it requires, it's a fairly complicated L'Hopital's rule. So I'll skip some of the details, but if you compute this, this is equal to 1 over e, which is smaller than 1, and so this series converges. Okay, so we see some examples of using the ratio test.